Okay, good afternoon, everyone. I want to welcome you to my lecture today. Of course, today we're actually going to focus on probability distribution in real life application. Before I get started, I actually want to make some announcements. I want to believe those of you at the back, you can hear me, right? Okay, thank you so much. Um, I want to emphasize that attendance of lab is very, very essential, very crucial to doing well in the course. Because whenever you get assignment, there's always going to be you're always going to have a question that we're going to ask you to implement using R. If you attend lab and you need some kind of clarification, I advise that you meet with me during my office hour. I've extended now my office hour. I have Tuesday 10 to 12, Thursday 10 to 12. So Tuesday and Thursdays, you can be anywhere in the world to attend my office hour because I conduct that on Zoom. So I want to appreciate those who visited me yesterday. Continue to visit if you need clarification, particularly about lab. Because imagine you have issue with importing data into R. There's absolutely nothing you can do if you cannot import data. That's very, very important. So, and that's why if you don't get it during the lab, make sure you connect with me during my office hour. I'm actually going to walk you with all of that. Okay. I want to go into today's topic. We started this probability on Monday, and we're going to continue from where we stopped. Okay. In the outline, I'm actually going to talk about the probability distribution for discrete random variable, the probability distribution for continuous random variable. Okay, I'm actually going to walk you through all of that there with illustrative examples. Now, let's get started. I'm actually going to start with stories, and I need you to pay attention. Statistics is like a story that goes on and on and on. Now, why do we find ourselves doing probability distribution? I want to explain that. What is the essence of probability distribution? In a stochastic environment, in a world where we got variations, of course, I told you the other time, we want to understand the world. And let me tell you this. If you actually have a motive of understanding average and the spread, there are two major statistics that we look up to in data set. Two major statistics where we want to talk about from descriptive angle. We want to know about the average. Why? Because when I collect data on height, on weight, on blood pressure, on stock price, there's variation. That's why I call variable. Okay? We're looking for a particular data point that will represent others. That's what we mean by average. And you know what? If I want to know because in the measures of average, we have three of them. We talk about measures of Sarah. mean, median, and mode. If you really want to understand which of the average measures of center is appropriate, then you need to be able to understand the probability distribution. And not only that, when you get your center, we also want to look at measures of spread. We're looking for a way to check on how that particular data point that represents the center, we want to see whether it's a good representative. And that's why we need to see how other data points spread. How? From that. We got some, the measures of spread. We have different kinds of measure we can use, like range, interquartile range, variance, standard deviation. But what will determine the appropriate one to use is when you understand the probability distribution of your random variable. So probability distribution of random variable is the key. It's actually going to point to the right technique of measures of center to use and the right technique of the measures of spread to use. And that is the reason why we need probability distribution. Now, when you're talking about probability distribution, we normally talk about probability distribution of a random variable. I told you, when you're conducting research, what is your random variable? What are you working on? A doctor may be working on blood pressure. Somebody in economy may be working on inflation rate. Or somebody elsewhere may be interested in the numbers of hours students study in a week. That is a variable. Now the question now is, we got two types of variable. Okay, if you really want to know, what is the probability distribution that work? Because we got probability distribution for discrete random variable. We also have probability distribution for continuous random variable. So because of that, variable can be divided into two: discrete, continuous. By discrete, when you have a random variable that can be expressed as a whole. Now, so I said possible value that can be listed: 0, 1, 2, 3, 4, 5. Those are discrete random variable. The probability distribution for discrete random variable is different from the probability distribution for continuous random variable. What do we mean by continuous random variable? When you have possible values, you believe that a particular variable in an interval, temperature, like rainfall, amount of rainfall, blood pressure, and so on like that, they are all classified as continuous random variable. A researcher needs to first understand what is the variable am I working on? What is the nature of the variable I'm working on? Is it discrete or continuous? Now, if it is discrete, then how do we apply probability distribution for discrete? And what do we even mean by probability distribution in the first place? Probability distribution will give us two fantastic ideas. Number one, okay, it's going to enable us to know the possible values your random variable can take. The possible values your random variable can take. And not only that, it's also going to let you know the number of time each value occur. The numbers of time each value occur. Now, I'm going to demonstrate with this example now. The way we get our random variable, we can get it in different ways, like the way we get data. We've done it in this class. It's either you conduct a survey or you conduct an experimental study. Let's say, for instance, you perform an experiment with a coin. I'm demonstrating this guy now. Oh, give me 1 second. I'm actually demonstrating this guy now. I perform experiment with a coin. I chose the coin 3 times. Before we go into the experiment, you got something in mind. A philosopher said, and I quote, a mind can never be empty. There's always something occupying our mind. A politician wants to win election. He has winning. He or she has winning. He needs our mind. A business person want to make profits. Students want to have an excellent grade. We always have something in our mind. Before tossing this coin 3 times, what you have in mind is what is going to form your random variable. Okay, maybe I'm interested in the number of eggs that will show up. And that's why here, you're going to write, you're going to use an uppercase letter. At times we use X, we use Y, we use Z. You're going to say, let S represent the numbers of eggs. You know what you want. You define what you want. Okay. Now, if you now take a look at what I have here now, these are the possibility. These are the elements in the sample space when I toss a coin 3 times. But you know what I want to do now? I want to assign numbers, assigning figures, numerical values to the elements in the sample space. That is what we call random variable. Okay, so what I'm going to do right now, I'm going to come here. How many heads? Since I've defined my head ahead of time, I got 3 head here, got 2 here, we got 2 here, we got 2 here, we got 1. Sorry, that should be 1. Give me 1 second. Okay, yeah, this guy. So that should be, I got 1, 1, and 0. Now, because of what I see now, I'm actually going to call my state space of the random variable S to be 0, 1, 2, 3. And after having that, I'm actually want to know what is the frequency of 0? How many times does 0 occur? For what I'm seeing here, 1/8. How many times does 1 occur? 3/8. How many times does 2 occur? 2 times out of 8. Or 3 times out of 8. How many times does 3 occur? 1 times out of 8. Then you know what I'm doing? I'm assigning probability of occurrence to each value of the random variable. We can do that when we're working with discrete, where we assigning probability to each value is more or less like assigning weights. You try to tell the world they are not equally weighted. That's what it means. Okay, now, when you talk about random variable now, and also I say it's a variable whose value is a numerical outcome of a random phenomenon. We did random phenomenon in this class. When you perform experiment repeatedly under similar condition, you have different results. And that's why I've demonstrated that using this. Now, this is where statistics is going to come. Statistics have rules. If we're talking about probability distribution, particularly for discrete random variable, then we got some statistical properties of probability. So number 1, we assign probability to each possible outcome. Because why to each possible outcome? Because the random variable is discrete. And the probability assigned has to be non-negative. Is that 0 or more than 0? And another thing we need to pay attention to, the addition of probability must be equal to 1. What is the implication of that? If the addition of probability is not equal to 1, whatever basic statistics you're going to compute from the data will be wrong. I'm going to say that again. The addition of the probability values have to be equal to 1. The moment it is 1, start celebrating. It means that probability function is legitimate. Then I can use it to figure out the mean, or maybe the average, the center, or the spread, and so on like that. I want to demonstrate. Look at this example now. Example 6.2. Let X be the number of bases for a randomly selected about. Now when you take a look at the X, the number of bases, so they know it's going to go from 0 to 4, and each of that has their corresponding probability. Okay, situation where you have a probability value for possible values of a random variable. The random variable is discrete. Now, first question said, is this a legitimate probability distribution? To be able to answer the question, you actually need to add up the probability. Okay, you're going to add up this guy. And if it gives 1, then it's a legitimate. In this case, it gives 1. And you can also answer probability questions. If it doesn't give 1, if the sum doesn't give 1, when you compute probability, when you compute what is of statistical interest, they're going to be wrong. Now I want to find the probability for a randomly selected about. What is the probability that the player got at least 1 base? At least 1. Of course, at least 1 is going to be greater or equal to 1. So which means I'm going to start summing the probability that's associated. At least 1 means I'm actually going to add this guy. 1, 2, 3. That probability together, and that will give me 0.247. Or I use the law of complements. Okay? I just wanted to take note of that. Now, right now, on the discrete, I've walked you through how to generate probability distribution. Okay, given the possible values of discrete random variable. I started from way of experimenting, and you saw possible possible element in the sample space, and we assign numbers to that based on the variable of interest, and putting into consideration the numbers of times a particular value occur, we're able to get the corresponding probability. But right now, why are we doing that? Oh my God, we are doing that because we actually want to figure out 2 basic statistics, 2 basic, center and spread. What do I mean by center? Now, that's why I said you see center and spread of a probability distribution, which means if I want to get the center, if I want to get the spread, then I need to be able to understand the probability distribution I'm working with. Is it discrete one or continuous one? Right now, we're dealing with the discrete. Now, if I want to find the average measures of center like mean in the distribution, okay, it's going to be called expected value of S, which is going to be measure of center. And now can I trust that value? I need a measures of spread. And that's why we go for standard deviation. So standard deviation always going to go with the mean. If you want to know how mean can be trusted, we need a standard deviation. Because the mean actually is the center. And because we're never going to be, I don't know why that happened in the world. We're not going to be, all of us are not going to be at the center. You're going to have some that are, movement away from the center, whether to the right or to the left. Okay, so whether to the right or to the left. Okay. Now, if that actually happen, then if I want to know the movement that occur from the center is actually called the number of standard deviation. If I want to know movement from the center, that's why when you calculate the mean, we always want to go for the standard deviation. How do we do that? If X, you can see here I say expected value of X. Don't forget, I've already defined my X as a random variable, which could be the number of the characteristics of interest. Take a look at this now. If I want to find that, what I'm going to do, I'm going to multiply each value of the random variable by its corresponding probability. Then I'm going to add it up. When I do that, I have the center, which is the mean. Now the next thing is I need a standard deviation. But you know what? Can I first find the variance? Let me tell you this. If I want to find the variance, you can see I have to subtract the center from each observation X. I'm going to square that. Then I'm going to multiply by the corresponding probability. Then I'm going to add it up. Now, when I have a sigma square, which is the variance, why do I need standard deviation? I'm going to tell you now. When you take it, let's say for instance, the random variable X, let's say the random variable S is height in feet. Each of the values that I have is in feet. When I find the average, the unit of the average is going to be the same as the unit of observation, each observation. Average is also going to be in feet. But when I calculate the variance will be in feet squared. And that doesn't make sense. Then we need a mathematical operation that will restrict that measures of spread to the unit of the mean. And what we can think about is if I take a square root of a sigma squared of something squared, then I'm actually going to have the same unit as the mean because we need that for interpretation. And that is the reason why we use standard deviation instead of the mean. Does that make sense? Okay, now you have this data set right now. There's a lot of variation here, 0, 1, 2, 3, 4, and they have their corresponding probability. And I want to figure out the center. Figuring out the center. Okay, this is how to do it. Okay, you can see I multiply 0 by 0.7531 I'm multiplying each value of the random variable by its corresponding probability. Then I add it all, and that gives us what we have. There to get the variance, take a look at what we do, which means we're actually going to use the mean that we got. You know, the mean was 0.401. We're going to be subtracting that from from each data point. When you are subtracting, what are you trying to do? You're looking at the distance between me, the center that represents the data set. You know, you are comparing that. You're looking at the distance of that to the rest of the observation. Why do you square? Oh, the reason why I squared is because the distance could be negative or positive, but it is positive distance that makes sense. So negative 3 squared is the same thing as 3 squared. And after squaring, we run into another problem of interpretation because the variance is going to have a square unit. It doesn't have the unit of the mean. Can we break it down? Can we restrict that unit of the mean? Then we find the square root of the variance. So the square root of the variance is what we call standard deviation. Statistics is like a story that goes on and on and on. We don't just do what we do. We got a reason why we do what we do. And what I expect you to do, just take your time. Okay, sit back, You don't understand? Ask question. Does that make sense? Okay. Now, you've seen all of that. Now, the more the standard deviation, the more it is spread out. Go ahead. So you said when we find the standard deviation, what is the probability? I really love that question. Like you really want to know what is the meaning of the standard deviation if I calculate it from data set? Now I'm going to tell you now. Um, I needed to take a look at this guy now. That was the average. Average of what? You know, we define S to be the number of bases, the number of bases and that is, and the numbers of bases and varies. It can be 0, it can be 1, up to 4. Okay? And we want to figure out the average. We're looking for a particular data point that will represent others. And we now arrived at 0.401. After arriving at 0.401, we now want to look at the gap between 0.401 and 0, 1, 2, 3, 4. What is the distance between the mean and each observation? The standard deviation is now going to say on average, okay, on average, okay, like 0.589 that I got here actually means that mean deviates away from the rest observation on average is 0.859. The way it deviated from 0 is different from the way it deviated from 1, the way it deviated from 2, the way it deviated from 3. But in a stochastic world, we need average. Does that make sense now? Okay. Now, and that is what, looking at this question now, a survey was conducted. Let us know the response of a randomly selected person to the question, what is the ideal number of children for a family to have? They ask, they ask men in this question, men. And the possible, when you ask a question like that, because different men will give different response. Some of them say 0, some of them say 1, and some of them say 4. And this guy is trying to say that probability is trying to say 4% of those that are investigated say 0 is ideal. 3% say 1, 57% say 2, and so on like that. We have this distribution now. We can find Sarah from it. We can find Sarah. We can find standard deviation from it. Why are we interested in the Sarah? Because there's a variation in response. Then we want to stand at the middle in a way at the center. Does that make sense? Okay. Now, when we use the formula, we got 2.38 on average. But let me tell you this. I need to focus on something now. Is 2.38 part of the random variable here? Is 2.38 part of them? No, 0, 1, 2, 3, 4. It's not part of them. And because of that, how can we trust that value that is representing others? That is why we need standard deviation. Does that make sense? Okay. Now, that's what we have right here. Okay. Now, I want to go into another. That is what we do. That's all about probability distribution of discrete random variable. Is super easy. You have a random variable. You have associated probability. You can figure out the mean. You can figure out the variance. You can figure out standard deviation. Do not pay too much attention to notations, but spend your time understanding what is behind notation. With that, statistics is going to be super easy. I want to welcome you to another probability distribution, this time around for continuous random variable. To notations, but spend your time understanding what is behind notation. Without statistics, it's going to be super easy. I want to welcome you to another probability distribution, this time around for continuous random variable. We just deal with the discrete one. For continuous random variable, we're talking about random variable that cannot be, the possible values of it cannot be listed. Instead, we talk about the intervals, the lies in interval. Okay. And such random variable, okay, we cannot be assigning probability to possible value the way we did in the discrete type. Then what are we going to do then? Then we're going to be talking about, since it is in the interval, okay, then we're going to be using what I call a curve. That's why you say density curve. Okay, if you want to get a density curve, if you plot an histogram and you try to connect bars, you're actually going to have a density plot. So because of that, and the kind of plot that I'm talking about is going to look, the curve I'm talking about is going to look like that. And you know what is going to happen, right? In the case of discrete, okay, a function qualified to be a probability function for discrete when you add the probability together and it has to be 1. But in the case of continuous, we can't do that. Then we are interested in the total area under a curve. Since we have a curve, the total area under a curve has to be equal to 1. Okay, and because of that, we need the idea of antiderivative. If I want to find the probability of a continuous random variable lies in an interval, then I need a probability density function. So what I'm going to do, if I identify that probability density function, I will perform an antiderivative. And it's going to be a definite, where I identify the lower bound and identify the upper bound. Now, when you take a look at this, number one property of this is that the probability should be non-negative, just like we have in the discrete type. Then I can find the probability of X lying between A and B. Oh, if X is the blood pressure of my patient, and I know the minimum blood pressure of my patient, I know the maximum, A is the lower bound, B is the upper bound, I may want to know what is the percentage of my patient have between this value and this value. That's what I'm trying to talk about here. Okay? And let me tell you this. Situation for continuous type, for continuous random variable, the probability that a random variable will be exactly a value like 5, probability that S equal to 6, probability that S equal to 10 will be 0 for continuous. But you know that exists for discrete, but for continuous is 0. You know why it is 0? It is 0 because when you talk about 5, we got infinite numbers of 5, 5.00001, 5.00002. There's a lot of them in the interval. Okay, and that's why you have that. And the total area under a curve has to be equal to 1, like I said, for legitimacy. Okay, now we got different kind of continuous probability distribution. Number one, I want to visit number one, uniform. What do we mean by uniform distribution? You remember the other time when I was walking you through sampling technique, simple random sample, right? The simple random sample means I actually want to take a sample from a target population and I give everybody equal chance. That's what we call uniform. It means in the entire domain of the function, the probability is going to be the same for everybody. If you guys are 1,000, One person will be 1 over 1,000, another person will be 1 over 1,000. Oh my God. Take a look at the shape. It's actually a rectangular shape. Now, if you take a look at this, I'm going to tell you now, a certain bus is equally likely. When you say equally likely, then the probability, every possible values in the interval has the same chance, the same probability. Now, this question say, a certain bus is equally likely to be anywhere from 0 to 20 minutes late. 0 to 20 minutes late. Oh, I know the lower bound, 0. I know the upper bound, 20. Now, let X be the number of minutes that the bus is late. The numbers of minutes that the bus is late. Don't forget, we are in a world where a bus can late 10 minutes, 15 minutes, and so on like that. Okay, from 0 to 20. Okay, because of that, okay, so if S is uniformly distributed, then it means based on information, we're actually going to have 0, 20 because they say between 0 minutes and 20 minutes. Our A is going to be 0, our B is going to be 20. Now, draw the density curve of X. If you want to draw the density curve of X, take a look at this. When you are talking about uniform, the function is 1 over B minus A. What is your B? The upper bound. What is your A? The lower bound. Here, A is 20. I'm going to say A is 0. B is 20. What is the F of S? 1 over 20. And that is why we have this guy here. Look at that. We use this because uniform distribution has that formula, 1 over B minus A. So, and that was why we get 1 over 20. So the 1 over 20 that we have, we're trying to say that exists for X lie between 0 and 20. What do we mean by otherwise? Otherwise means if X is outside 0 and 20, then F of S is 0. That's what it means. Now, if I have this now, what is 1 over 20? In decimal is 0.05. That was why you see this. Take a look at that. So if it has the same probability for any number choosing from 0 to 20. That picture now is rectangular, and that denotes uniform distribution, which means for any values of S in the domain, the probability is the same. Does that make sense? That's what we call uniform. And you know what? We can have something like this and we want to answer a question. What question do we always want to answer? In a stochastic world, we want to answer a question like, what is the center and what is the spread, right? Somebody here may say, okay, I know that this bus, come late between 0 and 20 minutes, we're going to be late. On average, can I have the average late time? Okay. So I'm going to tell you what you're going to use if you want to have the average. But before getting the average, can we have a way to compute some probability? Probability like, what is the probability that it's going to be late at least 13 minutes? At least 13 minutes is going to be probability of S greater or equal to 13. What am I going to do? Then if I want to compute probability for continuous random variable, then I need to perform an antiderivative on a given function. So I need you to pay attention now. I'm going to write something. Take a look at what I just did now. I want to find the probability of S greater or equal to 13. It means I'm going to start from 13 and go to the upper bound, which is going to be 13 to 20. What do I want to perform an antiderivative on? I already know 1 over 20. And you know how I got 1 over 20? Now, when you integrate this guy, you're actually going to have X over 20. You're going to have X over 20. And when you have x over 20, then you're going to put 20. You're going to put 13. And what you're going to do, you're going to be 20 minus 13 divided by 20, which is 17, which is 7 over 20, which is 0.35. So that is this place. Of course, you know the total has to be 1, but you are not interested in total. You are interested in 13 minutes and above, and that is going to be 0.35. Okay, if I want to do what is the probability that exactly 10 minutes, this is continuous, that probability will be 0. Okay, exactly 10 minutes, like exactly 10, it does not, it's actually going to be 0 for continuous random variable. Now, it's another one. I want to find what is the probability that is going to be late between 10 and 13. I'm going to go for the antiderivative again. I'm going to put 10 because they say 10 and 13. 10 and 13. And I'm actually going to perform an antiderivative of 1 over 20 dx. When you do that, you're going to see that you're going to get 13 minus 10 over 20. Okay, which is going to be 3 over 20, which is going to be 0.15. So which is just this area. Okay, and you can also solve some problem, like take a look at number 3. It said exactly 75% of the waiting time are below what value? You know, at times when we are in high school, you normally solve some equations, solve for x. We always solve for x all the time. Now here they know the probability value, but they don't know that particular value that is going to be below. If you want to know, this is what you're going to do. If you want to answer this question, it means the probability of x, okay, below, we don't know the number. I can say below is a small x, small value of x, and that probability has been given here to be 0.75. When I say below x, oh, below x, what am I going to do? Below x, I'm actually going to start from what is the lower bound given for the bus to late? 0, right? I'm going to start from 0. I'm going to end up in s, 1 over 20, 1 over 20, okay, 1 over 20, okay, ds, but I'm going to say the t instead of just the ds, okay? Here, I'm going to get t over 20. You plug in s minus when you plug in 0, that will give you s over 20. So s over 20 equal to 0.75. Then you solve for x. Solving for s will give you s equal to 15. Take a look at that. Okay, that is how to figure that out. Now, before I'm going to be done with uniform, what if they ask you to find what is the expected value? Let me see. Let me come here. Maybe they say, what is the expected value of x? Like, what does it mean when you are working with uniform? Please, I need you to pay attention. The mean is like, what is the average? Okay, the random variable here is actually, you know, the minutes, the number of minutes that very bus come late. Okay, now it's going to be a plus b divided by 2. So for this one, 0 plus 20 divided by 2. Does that make sense? That will be the average. Now, what about the variance? What is the formula for the variance? Okay, the variance of x. Okay, so the variance of x is actually going to be, or it's actually going to be b minus a r squared divided by 12. Some of you may be wondering, how do we get this? It's beyond the scope of this class. In theoretical statistics class, we normally can derive this. Okay, So which means your expected value of first and the variance of first depends on your lower bound and the upper bound. So whenever you are working with uniform, the examiner is going to tell you, oh, this random variable follow uniform distribution. And they're going to give you the lower bound, they're going to give you the upper bound, and you're going to be yourself, you're going to be the one that we use if you want to get the f of s, okay, for uniform distribution, like I said, is 1 over b minus a. Okay, that was how we got 1 over 20 the other time. B is 20, A is 0. Okay, now in our meeting on Friday, okay, before going there, let me say that some of you may be wondering, where do we have the density curve? At times, the uniform that we work on, we got so many different kind of continuous curve that, that are different from uniform, that will look like the one you have right now. Take a look at this guy right now. That is looking like a normal. Okay, and how do we get it? Some of you may be wondering, where does it come from? You can get that from the histogram. Do you see the histogram? Initially, you add histogram and you now draw the curve. Take a look at that. And what do you notice? When you increase your sample size, oh my God, increasing the sample size right now, what happened? You see that the shape is becoming, is going to converge to normal distribution shape. Okay, if you take a look at that. Okay, now, you know, when we have a normal curve, when we have curve, generally curve, we have two measures that we're interested in. We have the measure of center and the measures of spread. But we have three different under the measures of spread, mean, median, mode. And what determine what to use for center, that depends on the distribution of your data. If it is normal, we go for mean. If it is skewed, either to the right or to the left, we go for median or mode. And that's what I'm showing you now. You got the symmetric, right skewed, and the left skewed. And I told you for symmetric, mean and the median, they're going to be so close. The right skewed, the mean will be greater than the median. The left skewed, let me tell you this, if you want to figure out the center, the very first thing you need to do, what is the distribution of your data set, to be able to know whether to use the mean or to use the median. I'm going to stop here. I'm going to continue from here on Friday. Make sure you all stay safe and have a lovely day. Bye for now, everyone.